Hello everyone, this is statics lecture number 8. So far what we have been doing is we have been solving some problems based on Catenary. So if you haven't watched the previous videos, you please watch all the previous videos and come back to this video, right? Yes. So far we have solved 12 problems based on Catenary. So in this video we will start 13th problem. So before that we will just quickly go through the batches that are starting on Unacademy. And Unacademy has produced 7 rankers in top 20 and 15 rankers in top 50 and 169 plus rankers in overall they have cleared, right? Yes. And I'll tell you the batches are going to start soon on 29th September for 2021, 22 and 2023 aspirants. There is a 1 year batch starting for UPSC CSE starting on 29th September. And this schedule for 1 year batch, and these are the educators teaching 1 year batches. And there is also a 2 year batch starting on 29th September, and this is scheduled for 2 year batch, and these are the educators. And there is also 29th September, this is also a new batch called Weekend Current Affairs Simplified batch. And there's also on 18th October, there is a quality enhancement and answer writing program, and also top optional subjects launching this September. In every Sunday, you can avail, you can attend scholarship and you can avail some scholarship. And there's also a feature called Raise Hand, where you can raise hand and interact with educators if you have any doubt. And there's also a program called live mentoring program, and if you can't able to afford the fee, you can avail loan as well as, and if you purchase 1 year subscription, you will get 10,000 rupees worth books, 20 books. And let's crack it. Use my code prasanna10 for 10% off, right? Yes. Now we will be solving problem number 11 and problem number 12. So again I'll repeat, if you haven't watched problem 1 to problem 10, you please watch that and come back to this video, right? Yes. Okay, so we'll start problem number 11. Okay, so we just read the question, right? So very easy question. So what we have here is, so let me read the question. The solution, right? Yes. So a box kite is flying at a height h and the length L of the wire paid out and with the vertex of the catenary on the ground. Show that at kite the inclination of the curve to the ground is 2L times tan h inverse of h by L, and show that its tension at the grounds are W times L square plus h square by 2h and W times L square minus h square by 2h. So what we have here is, let us say this is the let us say we are flying a kite, right? This is the lowest point of the kite, right? Yes. So let us say here is the kite. Let us say here is the kite. Let us say this is the kite, right? Yes. Now a box kite is flying at a height h and a length L of the wire paid out and with the vertex of the catenary on the ground, right? So usually we will extend this from C to this B, but here we have only we are flying a kite from this ground level, right? So we have only this part. Okay, this is the vertex of the catenary, right? This is the vertex of the catenary. Let us say this is the ground, right? This is the ground level. This is the ground level. This is ground, right? So we are flying a kite, and you can see it is of height h, right? That is the distance from this kite to this ground level is h, and a length L of the wire paid out, and with the vertex of the catenary on the ground, that is the length of this wire, right? So you can see this is a wire, and here we are kite, right? So this kite is attached by this wire, and it is given that the length of this wire is L, right? Length of this wire is L. So length of this wire is L. Okay. Now how the diagram will be? Here it will be directrix, right? Here it will be the directrix. So it will be the directrix, right? This is what the basic definition diagram of catenary, right? So here we have a lowest point which is C, and here we have a kite, and this is H, this is L, right? Yes. Now there will be two tension here, right? There will be two tension here. What are those two tension? One is the tension T naught at C. These are very elementary, right? One is the tension T naught at this C, and other is the tension T that is acting tangential at A, right? So there is a two tension, we already know, right? There will be two tension T naught and T. T naught will act horizontal to this lowest point, and there will be tension T at A that is acting tangential to A, right? So there will be a tension A, so acting tangential to A, right? Yes. Now let this angle be alpha, right? Let this angle be psi. This is what the basic diagram is, right? Yes. Now this is a tension T, and there is a tension T naught, and there is an angle psi, right? Yes. Now we need to show that this angle psi is equal to 2L times tan h inverse of h by L. Remember, there is 2h here, don't get confused. This L is the hyperbolic tan, and this h is the height of the kite from the ground level, right? Yes. Now usually what we will do, we will assume this length to be equal to C, right? Usually we will assume this length to be equal to C. This is capital C. Usually we will assume this to be small c. And what is the length from A to this directrix? It is y, right? It is y. So this is y. Actually usually diagram will be like this will extend and so on. This will extend and so on. And here we will have an axis, and here we will have x, right? So we are not extending this, so we are only considering this part, right? Yes. Okay. Yes. Now what is this point? Let this point be x comma y, right? Let this point be x comma y. What is x? This is x, right? That is, this distance is x. So let me redo this again. So we will have something like this, and this is x, right? I'm just considering only the one half of catenary, right? So this point is a of x comma y. So what we need to show is, we need to show the angle psi is 2L times tan h inverse of h by L, and show that its tension at the ground R. That is, we need to show that tension T and T naught will take this value. That is what we need to show, right? So what we need to show is solution. So we need to show, the first thing is, we need to show the angle psi is equal to 2L times tan h inverse of h by L. This is the first one we need to show, and we need to show that tension. We need to show that tension T naught and T takes the value. Okay, let me write capital T, right? So tension T naught and T, tension T naught and T takes the values. So W times L square plus h square by 2h, and W times L square minus h square divided by 2h, right? Yes. So what is this tension? This tension is what? T is equal to Wy, right? So you already know both the formulas. So what is this tension? This tension T naught is Wc, right? So this tension T naught is W times C, and what is this tension? T is equal to W times Y, right? These are very elementary that we come across in all the previous problem. So this point is C, the weight is W, and this T Wy, right? So this tension is T times Wy, and this tension is Wc, right? Yes, Wc and T times Wy. Okay. Now we need to find the value of T naught. We need to find the value of T. We need to show that the angle of psi is 2L times tan h inverse of h by L, right? Yes. So we will show. So first what we will show is, we will show that the angle psi is 2L times tan h inverse of h by L, right? Yes. Now we know that what is S? S is equal to C times tan psi. This is the intrinsic equation of catenary, right? This is the intrinsic equation of catenary. Now if I find the value of C, and if I bring C to this side, I can able to say that we need to find the value of C first, right? We will substitute this value of C here, and then we can find psi. We can find psi easily, right? Let us mark this as equation number 1. So how to find C? So first what we will do is, we will find the value of C, and then we will substitute C here, so that we can find psi, right? Yes. Okay. Now to find C, now what is the relation between y and s? So we know y square is equal to c square plus s square. So what is this? This relation between y and s, right? So again I'll repeat, you just have to understand all the 5 relations. So you can see every problem we are just using all the relations, right? Yes, relation between y and s. Now at a, what is s? What is s? Now you can see s is the distance from the lowest point to any point. If the any point is a, what is s? S is same as L, right? Usually we will take from C to any point, the distance is L, sorry, the distance is C. From C to any point on this curve, that distance will take as S. Now I'm taking any point to be equal to A. The distance from CA is S. So at A, S is equal to L, right? Because this distance is same as L. So at A, S is same as L, right? S is same as L. And at A, what is the value of Y? At A, what is the value of Y? So at A, what is the value of Y? This Y is same as C plus H, yes or no? So this entire Y is same as, so let me draw this with different color. So this entire Y, so you can see this entire Y is same as this C plus H, right? C plus H. So C plus H is Y. So at A, and also Y is equal to C plus H, right? And also Y is equal to C plus H. So at A, Y takes the value C plus H, and S is equal to L. Now substitute here. So this will be y square is equal to C square plus S square. So at A, this will be what? C plus H whole square is equal to C square plus S square, right? C square plus S square. Now just expand this and find the value of C. So C square plus H square plus 2HC. This will be C square plus S square. So what I will do is I will replace S by L, right? Because at A my value of S is L, right? Okay. At A, this value is L. So this is plus L. So this C square will get cancelled. So we will have 2HC is equal to this L square, right? Because S is L, so we have L square. So we will have L square minus H square. This implies the value of C is L square minus H square divided by 2H, right? Yes. So we have substituted the value of C. Now substitute this C in equation number 1, right? So substitute C in equation number 1. Substitute the value of C, right? Substitute C in equation number 1. So substitute the value of C in 1. Substitute C value in 1. So we have S is equal to C times tan psi. Now at A, S is equal to L, and what is C? C is L square minus H square divided by 2H into tan psi, right? This implies tan psi is equal to what? 2HL divided by H square minus L square. Now can I take, what I am going to do is I am going to take L square common here. So we take L square common. What we have here is we have tan psi is 2H, sorry, L square minus H square, right? Sorry. So we will have 2HL divided by L square minus H square. I am going to take L square common here. So we will have 1 minus H by L whole square, right? I am just taking L square common here. So here we will have 1, here we will have by L. Something I am taking square common, this will be H by L whole square. This L will get cancelled. So what I am doing is I am writing this as tan psi is equal to, here we will have 1L. That 1L I am writing this as 2 times H by L divided by 1 minus H by L whole square, right? Here we will have 1. I am bringing that L to numerator, right? Both are same. Now what is this formula? So this is what? Psi is equal to tan inverse of 2 times H by L divided by 1 minus H by L whole square. So we know tan inverse of, we know, I'm going to write the formula, that 2 times tan inverse of x, right? 2 times tan inverse of x is tan inverse of 2x divided by 1 minus x square. This is the basic inverse trigonometric formulas. So you can see tan inverse of 2x divided by 1 minus x square, right? Tan inverse of 2x divided by 1 minus x square is this is what? 2 times tan inverse of x. So here x is h by l, right? So we have psi to be equal to 2 times tan inverse of h by l. This is what we need to show, right? 2 times tan inverse of h by l. So actually it is only 2, right? Sorry, it is not l. So 2 times tan inverse of h by l. So 2 times tan inverse of h by l, right? This is what the first thing we need to show, right? So sorry, we don't have l here, sorry. Yes. Now and what we need to prove is we need to show that the tension at the grounds are this and this, right? So to find tension, now what is the tension T naught? So T naught is W times C, right? W times C, this is the tension and T naught. So W times, what is C? We know C, right? What is C? C is L square minus H square by 2H, right? L square minus square by 2H. And what is T? T is equal to Wy, right? T is equal to Wy, and this is same as W times, what is Y at A, right? At A, T naught is equal to Wc, and at A, what is Y? Y is C plus H, right? Y is C plus H. So C plus H. So this will be C plus H. So this is same as W times, what is C? C is L square minus H square by 2H plus H. So this is equal to W times L square minus H square plus 2H square divided by C plus H. So L square, okay, yes, divided by 2H. So this is what? W times L square. So this will be what? Plus H square, right? So plus H square by 2H. This is what we need to show, right? So one tension is W times L square minus H square by 2H. The other tension is W times L square plus H square by 2H, right? This is what we need to show. W times L square plus H square by 2H and W times L square minus H square by 2H, right? So you can see, again I'll repeat, a box kite is flying at a height h and a length L of the wire paid out with the vertex of the catenary C on the ground. So that at a kite, we need to show this angle is 2 times tan h inverse of h by L, and we need to show the tension at the grounds are these two. That is, what we are doing is we are finding this angle psi and we are finding the value of Wc and Wy, and we are proving this problem very easily, right? Yes. So thank you. In the next video we will continue solving 14th problem, right? Thank you.